This is my presentation on muscle metabolism. ATP is the muscle energy source. All muscle concentration is dependent on the energy source ATP. Energy is stored in various phosphate bonds. You can also think of ATP as a fuel. This is the breakdown of ATP as you can see in the following image. Energy storage. The body is constantly producing ATP because it uses a lot. Muscles are capable of storing energy, however, most commonly, energy must be produced. Building energy glycolysis. Glucose is the primary fuel. Glycolysis is the conversion of one glucose molecule into two molecules of pyruvic acid. Building energy, two types. There are two pathways of ATP synthesis dependent on the presence of oxygen or not. In anaerobic fermentation, there is no oxygen. In aerobic respiration, there is oxygen present. Anaerobic fermentation, as you can see in the following image, enables a cell to produce ATP without the need for oxygen, but the ATP field is very limited. Aerobic respiration, best known as a pathway of glucose oxidation, is also used to extract energy from other organic compounds, as you can see in the following image. Energy usage. During the course of exercise, for different mechanisms of ATP synthesis are used depending on exercise duration. They can be broken down into three stages: intermediate, short-term, and long-term. An intermediate energy is a short, intense exercise, such as a 100-millimeter dash. The myoglobin in a muscle fiber supplies oxygen for a limited amount of aerobic respiration at the outset, but this oxygen supply is quickly depleted. Until the respiratory and cardiovascular systems catch up with the heightened oxygen demand, the muscle meets most of its ATP needs by borrowing phosphate groups from other molecules and transferring them to ADP. In short-term energy, as the phosphagen system is exhausted, the muscle transitions to anaerobic fermentation to buy time until the cardiopulmonary function can catch up with the muscles' oxygen demand. During this period, the muscles obtain glucose from the blood and their own stored glycogen. The pathway from glycogen to lactic acid is called the glycogen-lactic acid system, and it produces enough ATP for about 30 to 40 seconds of maximum activity, such as playing basketball or running completely around a baseball diamond. In long-term energy, after 40 seconds or so, the respiratory and cardiovascular system catch up and deliver oxygen to the muscles fast enough for aerobic respiration to meet most of the ATP demand. Aerobic respiration produces much more ATP than glycolysis does, typically another 30 ATP per glucose. Thus, it is a very efficient means of meeting the ATP demands of prolonged exercise. Once rate of oxygen consumption rises for 3 to 4 minutes and then levels off at a steady set in which ATP production keeps pace with the demand. In exercises lasting more than 10 minutes, over 90% of the ATP is produced aerobically. For up to 30 minutes, the energy for this comes about equally from glucose and fatty acids. Then, as glucose and glycogen are depleted, fatty acids become the more significant fuel. I hope you enjoyed my presentation on muscle metabolism. Thank you.